All right, let's take a quick look. I just want to zip through a bunch of problems to help you guys kind of prep for the test. So if we get through this today, remember, I would be willing to give you a freebie attempt tomorrow. You don't even have to do it. But if you want to do a freebie attempt on the test, remember, that's one that can't hurt you. I'll toss it if you don't like it, right? Otherwise, you'll just have break to, kind of get ready. Right. But this way you have an opportunity to maybe just get this one out of the way before spring break, right? Which if I were you, I would appreciate. That's what I would want, is to try to get things off my plate before spring break, okay? All right, so multiplying, so easy, straight across, right? We're just gonna multiply straight across, but what do we have to do to these fractions? Got to factor them, don't we? Right, so let's look at how we would accomplish that. How about that guy right there? What does that factor into?
Y times 1
times y squared
minus y plus 1.
Okay. Give me thumbs. Everybody get that from our pattern? Good. Okay, good. That's what I want to see. Lots of thumbs on those. And so, is that trinomial going to factor?
No.
Never, right? Because it's part of one of our sum or difference of cubes patterns, and the trinomials never factor. They're always prime. Good. How about this guy? What's that factor into?
Y plus 1 minus y plus 1.
Good. Difference of squares pattern. I'm liking this. That's good. And we could even, we'll multiply by, this one's already factored, isn't it? Right? So we've already got y minus 1 times 3y. And when we multiply fractions, we just extend the division bar and multiply straight across. Okay, now what?
Cancel out.
There we, okay, but before we cancel, exclusions, right? We need our exclusions, don't we? Right, so our exclusion list, what are values that y cannot be? 1, negative 1, 0. Because of that factor, and that factor, right? Okay, now we can cancel. Good. So what cancels?
Y plus 1 y minus 1.
Okay, y plus 1 and y minus 1. So that cancels with that cancels with that. And we get our final answer. Just looks like on top, I've just got that guy, right? Do I need parentheses if I only got one factor? Nope. It's by itself, so I don't even need parentheses. Y squared minus y plus 1 over 3y. So there is my answer. Make sense? Okay, you guys, that's probably just warm-up stuff, right? You're good at all of that. So what about this one? Thank you. And maybe you guys can decide if you even want to finish this one. You may not even want to take time to finish it, but let's at least get it set up here. So what would we do first? We're doing division, right? Factor everything. Good. So we've got our first fraction. Top factors into what? Our denominator is already y minus 1 divided by almost factored. Top is already factored, right? Y plus 1 divided by, what can I do in the bottom? Take out a 2. There we go. Yeah, take out a 2. Okay, good. Now what?
Keep it, change it, flip it.
Okay, but
Keep it, change it, flip it.
You can cancel out negative y minus negative.
okay, I'm getting lots of suggestions here. But what there is, I'm going with some of them, but we want to do things in order here. What do I have to do before flipping? Exclusions, right? And remember why? There's a reason for that. Because some of these exclusions might go away when I flip this fraction, right? I may not see them anymore, but anytime I have a denominator in a fraction, I have to exclude zeros of that, right? So before flipping, we start our exclusion list. What can y not equal? 1. So far, right? Okay, good. Now we're gonna flip. Okay, so there was a suggestion here. Do I need to get a common denominator? No, I don't need. When do I need common denominators?
Adding,
Adding,
subtracting.
Adding or subtracting only, right? Though that's a little tougher. Multiplying and dividing is way easier because I'm gonna end up multiplying straight across. No need for common denominators, right? So I'm gonna flip this guy. And then what's that gonna give me? Okay, so I'm gonna get, first fraction stays the same. I'm gonna put parentheses around this because we're gonna be multiplying. And I'm gonna multiply by the reciprocal of this guy. So that puts the 2y minus 1 on the top and the y plus 1 on the bottom. And now we can just extend our division bar, right? And multiply. Okay? So at this point, now what do we get to do?
Add to exclusions.
Oh, add exclusions. Very good. So what do we add to our exclusion here? -1, exactly. Okay, because of that guy, right? Okay, we got our exclusion list done. So now what?
Cancel.
Cancel. There we go. We cancel like factors. What cancels?
Y minus 1, y plus 1.
Okay, and so our final answer then, we've got nothing, 1 on the bottom, so I don't even need to write it. There's no denominator anymore other than 1. On the top, I just get 2 times the quantity y minus 1. So there's my answer. Good? Okay. All right. Okay, real quick, what's my LCD going to be?
X
X
minus
minus 1.
There you go. Okay, x times x minus 1. Okay, let's add these up. So adding, this is a little tougher. Now we're adding, so we are going to need a common denominator. What do we have to do first to get there?
factor.
Find the LCD.
Factor. Okay, so first fraction, we've got 12 on the top. What about our denominator?
X plus
X.
4 squared.
Okay, plus second fraction is already factored. So do I need to multiply the first fraction top and bottom by anything?
No.
No, it's good. How about the second fraction?
Multiply it by x plus 4.
There, okay, good, because I need an x plus 4 squared and I've only got an x plus 4. So I'm going to multiply this guy by x plus 4 over x plus 4. And now I do have a common denominator, don't I? X plus 4 squared. Okay, so I can write this as one big fraction with my common denominator, x plus 4 squared. What about the top? What's that going to give me on the top? When I'm adding fractions.
48 times.
48.
Oh, you're adding 16. It's almost 16 times x plus 4, right?
Okay, and you did a bunch of stuff in your head. So you're essentially doing this, aren't you? You've got this numerator plus that numerator, right? So in the top, I'm going to take this step by step. We get 12 plus 4 times x plus 4. And then you guys already pushed into the next step, which is just simplify the numerator into one big expression, right? I would distribute the 4 combined like terms, and then we would get 4x plus 28, is that right?
Yeah.
Over x plus 4 squared. What else? Okay, exclusions, good. So x cannot equal,
-4.
good. Okay, are we done?
AK's law.
Maybe, right? But so what we've done here now, let's kind of think about this as a process. We're done adding. We've added everything up, and that's our answer. But now we're back to the very first problems we ever did in this unit, where what'd you guys do? You just simplified rational expressions. We got a rational expression, which may or may not be simplified. It's not in this case. What do we always do to simplify?
Factor everything.
Factor everything. Bottom's already factored, right? In the process of adding, we ended up factoring the denominator. That was part of the process. But the numerator still needs to be factored, doesn't it? So what could I factor out of the top? What am I left with?
X plus 7.
Okay, so nothing cancels, right? So that's our answer. Okay, but we do want it factored. Okay, give me thumbs. You good? All right. Okay, simplifying complex rational expressions. What's our strategy with this? If we have fractions divided by fractions.
You get a single fraction on top and on the bottom, and then it's stuff.
Okay, good. Single fraction on the top, single fraction on the bottom, flip and multiply by the bottom, right? Okay, so the bottom, we could just write that as, we'll just write that as being divided by 1, right? Okay, on the top, how would I, talk to me about the top. What would I do?
On your common denominator.
Okay, common denominator between the two fractions, right? So that first term, I probably want to think of that as a fraction, maybe even write it as a fraction. How would I write it as a fraction?
X over 1.
X over 1. Okay, good. So then on the top, we're going to get, we've got X over 1. I'm going to give myself a space in case I need to multiply top and bottom by something. Minus X over X plus 6. Bottom is already done. So what would I need? Anything I need to multiply top and bottom by in this term?
X plus 6.
X plus 6. How about the second term? All good. So in my numerator then, I've now got a common denominator, right? There's my common denominator, X plus 6. So I can write this with a common denominator, X plus 6. What's my numerator going to be? Well, I'm going to have first numerator minus second numerator, right? Good. Bottom, already done. Bottom's been done. I'll just do that to remind us. That's one big fraction that's already done. Okay, top's not quite done yet. What could I do?
Squared.
X squared plus 6x.
Good, okay, we're gonna distribute the X. And in the top, that's gonna give me X squared plus 6X minus X. What's that?
Plus 5.
Over X plus 6. All divided by my bottom fraction, X plus 5 over 1. Okay, now what?
Keep it. Well, exclusions.
Exclusions. What can X not equal?
Negative 6.
Negative 6. Okay, now what?
Skip
Keep
the
it chain.
multiply.
Okay, flip and multiply.
Yeah, skip.
Okay, so we end up with X squared plus 5X over X plus 6 times 1 over X plus 5, right? And we can just extend this bar. Okay, so in the bottom, I've got X plus 6 times X plus 5. What's that do to my exclusion list?
-5.
What about the top?
Factor it.
Still got a factor, don't I? How could I factor the numerator?
X.
Take an x out. Okay, so what happens then? Yeah. Look at that, we get some cancellation. And so our final answer looks a little simpler. We just get x in the top by itself and x plus 6 in the bottom by itself. There's our answer. Good? Make sense? Okay. Okay, what about this?
1/a plus 4.
There you go. So let's turn this, take these negative exponents and let's turn those into fractions. Always, right? So this looks like 1/a plus, let's write 4 as a fraction. 4/1, all divided by 1/a minus 4/1. Okay, talk to me about the top. What do I need to do?
Common denominator.
Okay, so what do I need to,
Multiply the second fraction by a/a.
bottom?
Same thing.
Same thing. Okay, what's that give me? In the top then, I've got my common denominator a, and in the numerator I'm going to have first numerator plus second numerator. 1 plus 4a, everybody agree? So I'm just going to write that as 4a plus 1. In the bottom, same thing, right? I've got my common denominator of a. In the numerator, I'm going to have 1 minus 4a, right? Make sense? Okay, now what? Okay, but before I do that, exclusions.
0.
A cannot equal 0, good. Now we can, what do you guys say, skip, flip, multiplies that in?
Keep it,
Yeah,
change, flip
that's
it.
it.
Keep change, flip. Keep it, change, flip.
Keep it, change it, flip it,
No,
okay.
There you go. Keep, change,
Well,
flip. He likes our idea better.
So 4a plus 1/a times the reciprocal, a over 1 minus 4a. I can extend my division bar, and it looks like I can cancel some stuff. Do I need to include any other exclusions?
Yes.
Yeah, negative.
1/4.
1/4 from that factor. And I get my final answer. Right? Final answer just looks like 4a plus 1 over 1 minus 4a. Can't do anything else, right? Good? Okay. Okay, what if I'm dividing a polynomial by a monomial?
Factor at the top.
Okay, don't need to.
Oh.
I mean, you could, but you really don't need to, right? If I'm dividing by a monomial, this is where I can make this really simple. This does not have to be a complicated process. I can just split this up into separate fractions and reduce. And they're easy to reduce because the bottom is a monomial. So I can just use properties of exponents to reduce, right? So if we do that, if we split this thing up, everybody see this now, what we're going to get? I'm going to get my first fraction, 24a squared over my common denominator, 4a, plus my second fraction, when I split that denominator, is just 4a over my common denominator, 4a. We see the advantage of that? Then this becomes a problem we could have done a long time ago, right? We could have done this at the beginning of the previous unit, just using properties of exponents. We do need an exclusion here. What's my exclusion? A cannot equal 0. But then we can just simplify. We'll take this term. Look, 24 over 4 becomes what?
6.
So that's 6. And then a squared over a becomes a. There you go. plus, how about over here? 1. Everything cancels to 1, right? So that just becomes 1. Done. Easy. So when you're dividing by a monomial, I mean, you could follow the same process you do for dividing by a polynomial, but it's way easier just to split the fraction up and simplify each term separately. Okay? It's harder when you're dividing by a polynomial. So what would I have to do here? Long division, right? How come I can't use synthetic division? Okay, because the bottom is x squared, right? The bottom has to look like x plus a number or x minus a number for me to use synthetic division, right? That's not what's going on there. So yeah, we would need to use long division, so we just set up our division bracket. What goes inside? Tell me exactly what to write inside.
X to the fourth plus 0, x to the third.
Good.
Plus 6x squared plus 6x plus 25.
Okay, what goes out front? X squared plus 3. So what is the first term in my answer?
X squared.
X squared, exactly, because I'm going to take the first term out, or inside, divided by the first term outside, and that gives me x squared, right? So now what do? Distribute, good, I'm going to multiply, so that gives me x to the fourth plus 3x squared. Now what? Subtract. So remember, I'm going to put the whole thing in parentheses and subtract vertically. X to the fourth minus x to the fourth cancels. 0 is 0, right? 6x squared minus 3x squared is 3x squared, and I'll just bring the rest down and go again. Okay, what's next? 3. Okay, and again, the reason why is because my leading term inside divided by my leading term outside just gives me plus 3. So I distribute, right? I just, rinse and repeat here, right? I'm just going to do the same thing. I'm just going to distribute and subtract. So I get 3x squared plus 9. And when I subtract, what happens? Okay, so we get those cancel. What do I get here? 6x. I get 6x minus 0 just gives me 6x, and 25 minus 9 is 16. Can I go further? How do I know? Okay, good, because this has the leading term now has a smaller power of x than the leading term in the bottom, so I'm done, right? This becomes my remainder, and what do we get then for our answer? Yeah, so if I take this original quotient, so what is this thing equal to? 2 parts to my answer. What's the first part?
X squared plus 3.
Okay, good. The polynomial part is x squared plus 3. Plus, what about the other part?
6x plus 16 over x squared.
Good, and the remainder is what remains over the original denominator, right there. So there's my answer. Good? Make sense? Okay. All right. Synthetic division, way easier and quicker, right? How would I divide this synthetically? Make my bracket.
-1 on the outside.
-1 on the outside. Okay, so the 0 of the denominator is -1. What goes in the top? Okay, and that's just coming from here, right? And what's the process? Bring down, oh, what I forget to do in my bracket, by the way? Yeah, I need, okay, underneath the constant, I'm doing the remainder box, right? Okay, so I've got 1. Now what? Multiply, add, so I get -10. Okay, so that gives me +10. Multiply, which gives me what? Okay, so what's my answer then? If I write this answer out,
X squared minus 10x plus 18.
okay, good. So there's the polynomial part. X squared minus 10x plus 18 plus what?
-15 over x plus 14.
-15 over my denominator, x plus 1, and we got it. Yep.
Could you say minus 15?
You could. Plus, if the numerator consists of a single term like that, right? A negative in the numerator is the same as a negative out front. So I could write that as -15 over x plus 1 also. That's fine, either way. Okay? Okay, we don't have to do this whole thing, but how would I set it up? That's all I want to do here. So it tells me for the given polynomial p of x and c equals -1, use the remainder theorem to find p of c, right? So really what you're doing here is you're finding p of -1. How would I do that synthetically?
-1 on the outside.
Okay, good. So -1 goes on the outside. And then what would my coefficients be?
Or 4.
4.
4, 0, 3, 0, -6.
Good, and that comes from there, right? And then the answer is there, right?
Yeah.
So whatever this is equal to is just coming from right there, right? The remainder, when I divide out that quotient, is equal to the value of the function at that place, right? At -1. Okay, good. All right. Okay, how about this guy? Last two. And this is pretty fresh because this is the most recent stuff we've done. Use synthetic division to show that the number given to the right of the equation is a solution of the equation, and then solve the polynomial equation. Okay, so don't lose sight of what's being asked here. Sometimes with people that aren't very far along the math journey, they sometimes lose sight of what they're trying to do, right? You jump into these things and you're smart, you want to get going on stuff, but it's asking you to solve an equation. So what should your answer look like? Okay, but the factors are part of the journey. They're not the answer. What's the answer going to be? It's going to be, values of x, right? I'm going to get number values of x. Because whenever I solve an equation, don't lose sight of what you're doing. Solving an equation just means you're finding the values of the variables that make the equation true. So we'd say the values that satisfy the equation. That's our journey here, right? We're searching for the values of x in this case that satisfy the original equation. Okay. Pretty soon we'll talk about some things we would know, like we don't know this yet, but pretty soon we'll know that the number of possible values that we're going to find is either going to be 1 or 3. We haven't talked about that stuff yet, but later on we'll have some more insight into what should we expect to find when we solve equations. Right now we're just kind of focusing on the process. Later on we'll get into more interesting theory that relates to this. Okay, so they tell us one solution, right? They're telling us right here that 4 is a solution. How is that? First of all, we have to verify that. How could I verify that?
You get a remainder of 0.
Okay, I would have if I were to evaluate the expression on the left, I would need to get 0, wouldn't I? Everybody agree? Okay, which makes sense, doesn't it? That makes the equation true. By plugging 4 into this equation, if I get 0, then I get 0 equals 0, which is a true thing, right? So that makes it a solution. So we would do that using synthetic division, right? So what goes in the top? Okay, what number goes out front? 4. Not -4, right? This time they're telling us that 4 is the 0, right? So that's the number that we plug in. And if we're just verifying that this is a solution, what do we already know has to happen in this remainder box?
0.
We know we got to get 0 there. If we don't, then this is not a solution and we can't do the problem, right? Because we couldn't solve this otherwise, right? That 4-term polynomial is clearly not going to be soluble by grouping. Grouping's not going to work. We failed the ratio test. Okay, so let's do this process. What do we get? 1, 4, 2, 8, right? Hey, what do you know? Okay, so we're supposed to show that the number given to the right is a solution. Check, we just showed it. Okay? How does this help us?
It's more easily factorable.
Okay, it makes it more easily factorable. Yeah, what does this tell us, essentially? What this tells us is that our original 4-term polynomial broke up into x minus 4, which we already know that solution, right? We don't even need to worry about that one. But more importantly, the other factor that this breaks up into is this quadratic one. What's that one?
X squared plus 2x.
Okay, now we're getting somewhere, right? Because now we've got a basic trinomial that's easily factored. How does that factor? X plus 5, x minus 3. So what are my solutions then by the zero product property? X equals 4, we already knew, but the other ones that we didn't know are, whoops, what's this one? Or, there we go. Okay, give me thoughts. That make sense? Okay. All right, last one. How about this? Factor f of x into linear factors given that k is a 0 of f of x. Well, k is -2 with a multiplicity of 2. Okay, so how could I do this one? Okay, good. We're going to do synthetic division twice. We know it has to work twice because the multiplicity is 2. So we'll make our synthetic bracket. What goes in the top? Tell me coefficients, everybody. 1,
3, -2, -172, -168.
and we already know what goes in the remainder box? 0. Okay, so we do the process. We know that k equals -2. So what goes out front? -2. Okay, because that's a 0, right? What goes out front is the 0. And what do we get? So 1,
-2, 1, -2.
-44,
88.
which gives us what? That's going to be 7. What is it? 84? Yeah, 84. -84. And then we get +168, and those add to 0. Good. Okay. So now what?
You use
Yeah.
those factors on the bottom.
It's -2 again.
Go again, yeah, okay, because we know that the multiplicity of that 0 was 2. So that tells us two things. I'm going to get a 0 again, and I get to use that again, right? And that all comes from the fact that the multiplicity is 2. Tells us we get to use this thing twice, and we get 0 twice when we use it. Agree? Okay, so now what?
1,
Bring down the 1.
-2, -1, 2, -42. 8 more.
So we got it. And then what's that tell us? Okay, so that tells us that our original f of x equals, what does this part tell us?
X plus 2.
X plus 2 squared. Good. That's what that and that are telling us, right? And the orange part tells us, what's the other factor? X squared minus x minus 42, right? So using synthetic division twice allowed us to get this other smaller factor that we can now deal with. So we go one more step. Okay, here's the multiplicity 2 factor we were given, and then we're able to break this one up into linear factors, what? Times. There it is. Okay, give me thumbs. How you doing? Think you got this?
Yeah.
All right.
Gonna ace it tomorrow.
Good.